Hi, today I'll be covering 1 and 2 sample confidence intervals for categorical data. So what is a confidence interval? A C% confidence interval gives an interval of plausible values for a parameter. The interval is calculated from the data and has the form point estimate plus or minus margin of error. Here's a quick review of the state plan do conclude process. State what parameter do you want to estimate and at what confidence level. Plan. Choose appropriate inference method, check conditions. Do. If the conditions are met, perform calculations, and conclude. Interpret your interval in the context of the problem. For the do portion, it's usually best to write out the specific equation for the confidence interval you're going to construct. For the conclude portion, a confidence interval is usually interpreted in this manner. We are C% confident that the interval from blank to blank captures the parameter in context. Be sure that your interpretation describes a parameter and not a statistic. Let's start with proportions. The first confidence interval we'll cover for proportions is a one-sample z interval. Before doing the calculations, you should always check the conditions. The conditions are random, the data must come from a random sample, 10%, the sample size is less than 10% of the population, and large counts, n p hat and n times 1 minus p hat is greater than or equal to 10. This is the equation for a one-sample z interval for p, where z star is the critical value for the standard normal curve, with C% of its area between negative z star and z star. P hat is the sample proportion, and n is the sample size. You can always do this equation using a special function on your calculator. Here, I'll show you how to do it with a TI-84. First, you choose stat, and then press test. And from the tests that are given, you choose one prop z interval. Enter all the values and highlight calculate and press enter. Here's an example FRQ you can use to practice. The next confidence interval we'll cover for proportions is a two-sample z interval. Again, we check the conditions, random, 10%, and large counts. This is the equation for a two-sample z interval for p1 minus p2, where z star is the critical value for the standard normal curve. You can also do this equation using a special function on your calculator. From the test provided, we click to prop z interval, and we enter the values and the confidence level, highlight calculate, and press enter. Here's an example FRQ you can use to practice for a two-sample z interval. Next are means. The first confidence interval we'll cover for means is a one-sample z t interval. Before doing the calculations, you should always check that the conditions are met. For one sample t interval, the conditions are random, the data must come from a random sample, 10%, the sample size is less than 10% of the population, and normal large sample. The population distribution is normal, or a large sample, n is greater than or equal to 30 is taken. No strong skewness or outliers if n is less than 30, and population distribution has unknown shape. This is the equation for the one sample t interval for mu, for means, where t star is the critical value for the t sub n minus 1 distribution. And similar to confidence intervals for proportions, you can calculate the interval using a special function on your calculator. Here we choose t interval, and you can highlight and select either data or stats at the top of the screen. If you choose stats, adjust your settings and choose calculate. If you choose data, adjust your settings. You'll have to have entered raw data into a list prior to doing this and choose calculate. Here's an example FRQ you can use to practice one sample t interval. Next is a confidence interval for two sample means. Before doing the calculations, again, check conditions, random, 10%, and normal large sample. This is the equation for a two sample t interval for mean minus mean, where t star is the critical value with C% of its area between negative t star and t star for the t distribution with degrees of freedom using either technology or the smaller of n1 minus 1 and n2 minus 2. Again, we can also use a calculator for this. We select two sample t interval, and we choose stats as the input method and enter in the summary statistics. Choose no for pooling, highlight calculate, and press enter. Here's another example FRQ you can use to practice two sample t interval. And to wrap up, remember that a C% confidence interval uses sample data to estimate an unknown population parameter, with an indication of how precise the estimate is and of how confident we are that the result is correct. Here's some additional cautions. Students often make mistakes when doing calculations for two sample proportions and means by hand, so I'd recommend using specialized functions on your calculator that I just covered. Also, make sure to check and write down the correct conditions for the confidence interval you're using. Students will often include the central limit theorem, sample size is greater than or equal to 30, and confidence intervals dealing with proportions when it is not necessary. Another mistake is to interpret a 95% confidence interval as saying that 95% of all the data values in the population fall within the interval. Again, the 95% speaks to the method of the test. It gives the overall success rate of the method for calculating the confidence interval. In C% of all possible samples, the method would yield an interval that captures the true parameter value.